Good afternoon, everyone. I have chosen the topic System of Particles and Rotational Motion for the demo class, and it is a CBSE class 11 topic. So this, as far as NCERT is concerned, this chapter is starting with a new concept, which is rigid body. Actually, a rigid is a very well-known word. In our daily life also, we use rigid for describing the characteristic of some person, right? So rigid means that person who is not flexible at all. The same idea is also applicable in case of a body. So a rigid body is defined as which cannot change its shape and size under application of any external force, however large it is, right? If I want to say in terms of the distance between two particles, I must say I have chosen any two particles, though the body is consisted of millions of particles. So the distance between any two particles in case of a rigid body will remain constant under any circumstances. However however large the force is, this distance is not going to change. So we can easily understand one thing: no real body is a truly rigid. It's just an idealistic concept, because if the applied force is enough, the object is able to change its shape and size. Though this chapter starts with this assumption that the body is a rigid thing. Now, what are the possible motions a rigid body can have? Children have already studied about motion in a one dimension, motion in a two dimension. That is a projectile motion. So I have given one example, that the box, as you see in the diagram, the box is moving across an inclined plane. So if I consider any two points in the box P1 and P2, I can also say that the velocities of P1 and P2 are also same. If the inclined plane is moving with certain velocity v, then P1 and P2 also having the same velocity, right? So this is the linear velocity, and this is also called a pure translational motion of the object. Similarly, if I consider a projectile motion, each and every particle in this object, it is having the same velocity at the particular instant of time. We are considering at a particular instant of time. So the velocity of all the particles are same. That is a translational motion again. Now I have just replaced the box in case of the previous example, a cylinder which is rolling across the inclined plane. So we can understand one thing: P1, P2, P3, P4, all these four particles, because of this rolling, is not having the same linear velocity. For example, P4, which is just in contact with the inclined plane, is having the least velocity, that is 0. But this is not true for P1, P2, P3. They are having different velocities, of course, but they are not 0. And here only the translational motion and a rotational motion differs from. In case of the translational motion, each and every particle will be having the same velocity at a particular instant of time, but it is not so in case of a rotational motion. Though in this example, in the present example, the object is rolling, at the same time it is also translating, right? So it is not a pure rolling motion, it is basically a combined motion. So this is the second category of the type of motion a rigid body can assume. The same example as I have showed previously. Now, if we consider the motion of a top, the motion of potter's wheel, of course the motion of a fan, and a merry-go-round, of course. All of these cases, object is rotating with respect to a certain axis, with respect to a particular axis, but at the same time the fan is not shifting from here to there, right? The merry-go-round is not shifting, it is not translating, basically it is only rotating with respect to a particular axis. So these are the examples of a pure rotational motion. So three types of motion altogether a rigid body can assume. First is a pure translatory motion, second is pure rotational motion, and third is a combined motion. Okay, now in case of a rotational motion, which is our point of concern in this chapter, we have to understand and we have to also take care of that about the axis of rotation, because as the chapter will progress, children will understand that this choose of or the choice of axis of rotation or consideration of axis of rotation is so important thing, because depending on this choice, basically the parameters related to rigid body changes. Anyway, here are two examples I have given. I am talking about this left example where the object is rotating, the rigid body is rotating in XZ plane and it is rotating across the y-axis. So this is a y-axis is its axis of rotation. On the other hand, in this case, the object is in the XY plane and its axis of rotation is Z. It is in XY plane or axis of rotation is Z. Okay, so axis of rotation is a such important thing in this chapter. Well, center of mass is something, a new concept. It is something that we need to consider a single point inside of the rigid body, though it is consisted of millions of particles, but we need to consider a single particle inside of the object, where inside or outside, sometimes it depends on the shape, where the whole mass of the object is assumed to be concentrated. For example, why we need to, what is the importance of considering center of mass? Because as I told you, it is consisted of millions of particles, but it is not possible to consider the dynamics of millions of particles, basically, right? So we have to consider a single particle's motion, which is just equivalent to the motion of the whole body, and that particular point is nothing but the center of mass. Calculation, there is a standard mathematical way out to calculate the position of the center of mass. I have taken for the simplest system is a two particle system. As you see, M1 and M2 are two point masses are at x1 and x2 respectively from origin. I have considered a two-dimensional case, sorry, a one-dimensional case, and in this case, the center of mass across x-axis will be following this equation. If instead of being in x, if it were in the y, then just it is going to be the center of mass across y. Similarly, if there is another dimension considered z, then these are the three equations for xcm, ycm and zcm, and this whole thing has been described in three different notations, right? These are nothing but mathematical forms only, where sum over of I, this is IMI, this is nothing but the mass of the whole body, and here I is considered to be 1 to n because I want to consider all the particles available inside of the body. It might be 1, it might be 10, it might be 100, it might be 10,000, whatever it is, all the particles available we need to sum over on each and every particle. Okay, I must say in this case, these three are the formulas of discrete particles, right? Wherever there is a discrete particles, we need to use this equation. Instead of being discrete particles, if there is a continuous, this is just a vector form, if there is a continuous distribution of particles, in that case this summation will simply be replaced by an integration. Just from the concept of the integration of mathematics, it can be written down, right? And using these equations as it has been written inside of the pink box, just by using these equations we have to calculate the center of mass of different shapes. There are few regular shapes, irregular shapes. Depending on that, depending on their shape, the position of the center of mass will be inside of the body, maybe outside of the body, like that. Okay, I'm closing the demo over here. Have a nice day.